Magandang araw po ulit sa inyong lahat at welcome back sa ating channel. Ang topic natin sa video na ito ay ang tungkol sa per unit system na ginagamit sa power system analysis. Pero bago tayo magsimula ay gusto ko munang pasalamatan yung ating mga subscribers na patuloy na sumusuporta sa ating channel. At iniimbitahan ko na rin yung mga hindi pa po nakasubscribe na mag-subscribe na po sa ating channel. Maraming salamat po at umpisahan na natin. Ang per unit quantity is equal to the ratio of the actual quantity and the reference quantity called the base. So, quantity per unit is equal to actual quantity divided by the base quantity. Okay? So, for example, meron tayong base voltage natin is equal to 220 kV, and then ang actual natin, ang actual voltage natin is equal to 223 kV. So ang ating voltage per unit is equal to 223 kV divided by 220 kV. So therefore it is equal to 1.013 per unit. Okay? So, another example, halimbawa, meron tayong base power which is equal to 100 MVA, and then meron tayong actual power which is 98 MVA. So, ang ating per unit S per unit is equal to 98 MVA divided by 100 MVA, which is equal to 0.98 per unit. So makikita natin na ang ating per unit is hindi lang laging less than 1. Pwede itong maging more than 1 depende rin sa ating actual quantity. Okay? So in analyzing power system using per unit system, so ang ginagawa natin dyan is nag-specify tayo ng dalawang base quantities, which is yung base power, S base, and yung ating base voltage. Okay? So ayan lagi yung ini-specify natin, S base tsaka yung B base. And then from these two base quantities, ma-determine na natin yung formula para sa iba pang mga quantities by manipulation of power formula and Ohm's law. Okay? Pero in order for all the electrical laws to be valid in per unit system, so we always use these following relationships. So, S base is equal to P base is equal to Q base. And also, impedance base is equal to resistance base is also equal to reactance base. Okay? So, yan yung mga relationships na kailangan nating i-consider kapag gumagamit tayo ng per unit system sa power system analysis para maging valid lahat ng electrical laws natin sa per unit system. Okay? So, from these two base quantities, itong ating base power at yung ating base voltage, and using the power formula, so power formula na S is equal to V times I, so makukuha natin yung ating base current. So, I base is equal to S base divided by V base. Okay? So, ang una nating equation na kailangan itandaan is itong isa na to is equation 1. Yan yung equation 1 natin. Yung actual divided by base, which is equal to per unit. And then ito is ating equation 2. Okay? So, equation 2 natin yan. And then, from the power formula naman na S is equal to V squared over Z. So, madiderive naman natin yung base impedance which is base impedance, is equal to V base squared divided by S base. Okay? So, yan yung ating equation 3. Equation 3. Okay? And then from Ohm's law naman, so meron tayong Ohm's law na formula which is V is equal to IZ. So, makukuha naman natin dyan yung ating base current is equal to V base divided by Z base. Okay? So, equation 4 natin yan. And then, from the Ohm's law pa din, ating Z base naman, C base is equal to V base divided by I base. Okay? So, yan yung ating equation 5. So, hindi naman mahirap tandaan yung mga formula natin, pero kung sakali nalimutan ninyo, madali nyo rin ma-derive kasi manipulation lang yan ng ating mga power formula tsaka Ohm's law. Okay? So, itong mga quantities na to, itong mga equations na to rather, is in terms of base values. Okay? Pero alam natin dito sa ating equation 1, ang ating per unit quantity is equal to actual divided by base. So, yung mga actual quantity naman is normally given na yan sa ating mga equipment. Like halimbawa, yung mga rating ng equipment, yung mga kVA, yung kV, impedances or reactances ng mga equipment. Given yan sa nameplate. Or isa pang source ng ating mga actual values rather is yung mga data sheet. Okay? So normally may mga data sheet yung ating mga halimbawa sa cable, sa ating mga transmission. So may mga data sheet yan. So kung alam mo yung length ng linya natin, and then sa mga table ng mga conductor properties, meron yung resistance per kilometer or resistance per foot, at meron din yung mga reactance per kilometer or reactance per foot. So i-multiply mo lang yung mga yon sa length, so makukuha mo na yung resistance at saka reactance. So makukuha mo na rin yung impedance using Z is equal to square root of R squared plus X squared. Okay? Or minsan naman, in-express na lang yung ating impedance sa linya as R plus JX. So, may mga pagkakataon din na kailangan nating i-convert yung ating base voltages from one base to another, which is kapag meron tayong mga transformers sa ating network. So, dahil alam naman natin na ang ating mga transformers ay may dalawang voltage levels. Meron tayong high side at low side. So, kapag meron tayong mga transformers sa network, kailangan natin i-convert yung base voltages from one base to another, or pwede natin sabing referred to primary or referred to secondary. Okay? So, for example, ito yung ating transformer na nakakonect sa network. Kapag mag-move tayo ng base from, let's say, from side 1 of the transformer to side 2 of the transformer. So, it doesn't matter kung alin dyan yung high side tsaka low side, basta side 1 tsaka side 2. At nag-move tayo in this direction. So, ang ating formula is V base 2 divided by V base 1 is equal to V rated 2 divided by V rated 1. Okay? So, kung ang ating base voltage is nandito sa side na to ng 1 at kukunin natin yung converted na base voltage dun sa side ng 2, so magiging V base 2 is equal to V base 1 times V rated 2 divided by V rated 1. Okay? So, iyan yung ating equation 6. Equation 6 natin yan. Okay? So, yung ano natin, yung mga conversion natin ng base voltages is pwede rin naman pa ganitong direction. Walang problema. So, kung pabaliktad naman yung direction mo, ito naman yung magiging 1 natin. 1 pala yun. And then, ito naman yung magiging 2. So, it doesn't matter kung anong direction yung movement natin ng base voltages. Basta, yung origin is yung 1. And then, yung final is, ayun yung 2. Okay? And then, lastly, meron naman tayong mga pagkakataon na kailangan nating i-express yung ating per unit impedance from one base to another base naman. So, ang magiging formula naman natin dyan is Z per unit new, meaning in new base, is equal to Z per unit in old base. So, itong old base na to ng Z per unit is, yan din yung given na value. Okay? So, pag sinabi natin old sa ating formula, is ayun din yung given. So, ang magiging ano natin is Z per unit old times S base new base, ibig sabihin, and S base old, or yung old base, times yung B base old divided by B base new quantity squared. Okay? So, yan yung ating formula para ma-convert natin yung ating per unit impedance from one base to another base. So, yan yung ating equation 7. Okay? So, in order to demonstrate yung paggamit ng per unit system sa power system analysis, i-solve natin itong problem na to. So, sabi sa problem, in the network below, solve for load current in per unit and in amperes. Use base power of 30 kVA for the entire network and 240 volts voltage in zone 1. So, naka-specify dito yung 240 volts is para lang sa zone 1. Pero, yung ating 30 kVA is para sa entire network. Okay? So, ang goal natin dito is kukunin natin yung mga per unit values ng bawat component sa ating network para makuha natin yung per unit current. And then, from the per unit current, makukuha naman natin yung ating actual current. So, ang isa-solve natin is yung per unit muna. Pero in order to come up with the per unit value, syempre, dadaan muna tayo sa calculation ng mga base values. So, pag meron na tayong base value at meron na tayong per unit, makukuha na rin natin yung actual. Okay? So, dito, hinati natin itong network sa 3 zones. So, ang paghahati ng zone is kung saan tayo may transformer. Kasi, dun sa point na may transformer, dun nagkakaroon ng different voltage levels sa primary at secondary. So, itong from the generator to the secondary, to the primary rather of transformer 1, ayan yung ating zone 1. So, hatiin natin yan dyan. And then, from the secondary of transformer 1 hanggang sa primary naman transformer 2, ayan yung ating zone 2. Okay? And lastly, yung zone 3 natin is mula sa secondary ng transformer 2 hanggang dun sa load. So, ang gagawin natin, isosolve natin yung mga base at per unit quantities per zone. Okay? So, una, ilagay muna natin yung ating mga base values. So, ang S base dito is base. SB na lang para mas maiksi. 30 kVA. So, for the entire network daw yan. So, SB dito is equal to 30 kVA. So, dito rin, yung SB is equal to 30 kVA. Okay? So, next is yung ating base voltage, which is VB is equal to 240. So, para dito lang yan sa zone 1. So, hindi sinabi na applicable yan sa zone 2 or sa zone 3. Okay? So, ngayon, i-compute natin yung ating base voltage sa source. So, VS source per unit rather, i-compute natin yung ating per unit sa voltage source, which is equal to voltage source, which is yung E divided by yung ating base, VB. Okay? So, yung voltage source natin, ayun yung E. Kasi sa generator, ang convention natin sa voltage is E, hindi V. Okay? So, sa voltage source per unit natin is equal to 220 C of 0 degrees divided by, ang ating base is 240. Okay? So, ito, volts in volts. So, ang ating voltage source per unit is equal to, divide natin yan, 220 divided by 240. Ang lalabas dyan is 0.9167 C of 0 degrees. Okay? So, lagi rin natin take note kapag yung mga quantities natin base is laging real number yan. So, wala tayong angle. Okay? So, yan na, nakuha na natin yung ating voltage source per unit. So, pero hindi lang yan yung ating component sa zone 1. Meron pa tayong transformer 2. So, since yung ating base power which is equal dun sa rating ng ating transformer at yung ating base voltage din is equal din dun sa primary ng ating transformer sa zone 1. So, pwede na natin sabihin na yung ating per unit reactance ng transformer 1 is equal to yung ating given na yung ating given na reactance do sa transformer, which is equal to 0.10 per unit. Okay? Since equal naman lahat ng mga quantities ng ating base tsaka do sa actual. So, meron na tayong per unit ng voltage. Meron tayong per unit voltage at meron na rin tayong per unit impedance or reactance dun sa ating zone 1. Pagdating naman sa ating zone 2, so ang given lang sa atin na base quantity is yung base power which is 30 kVA. So, yung ating base voltage na nasa ating primary ng transformer 1 which is nasa zone 1, kailangan natin i-convert sa zone 2. So, para magawa natin yan, i-recall natin yung ating conversion ng base voltage kanina. So, ito yung ating 1, ito yung ating 2. Okay? So, pag ganito ang movement natin from this side of the transformer. Okay? So, ang ating formula is V base 1, or 2 rather, is equal to V base 1 and then V rated 2 divided by V rated 1. Okay? So, ang ating base voltage dito sa side ng transformer na to, which is yung 2, VB dito is equal to yung 240 which is yung V base 1 sa ating side 1 ng ating transformer, and then V rated 2. So, yung rated voltage ng transformer dun sa zone 2 o sa kabilang part o sa kabilang side ng ating transformer, which is 480, divided by V rated 1, which is yung 240 din. Okay? So, ang lalabas dyan, ang base voltage natin dito sa ating zone 2 is equal to 480 volts. Okay? So, since meron na tayong base voltage, makukuha natin yung ating base impedance sa pamamagitan ng paggamit ng ating power formula, which is V base squared over S base. Okay? So, makukuha natin yung ating base impedance, which is equal to, ang V base natin dito is yung converted base voltage, which is yung 480 na, hindi na yung 240. 480 squared divided by yung ating 30,000, which is 30 kVA. So, pag kinalculate natin yan, yung ating magiging Z base is equal to 7.68 ohms. Okay? Ngayon, meron na tayong Z base. Ang sabi natin kanina, for all the other electrical loss to be valid sa per unit, yung ating C base is equal to reactance base is equal to resistance base. And then meron tayong given na actual reactance. So para makuha natin yung ating per unit reactance, reactance per unit is equal to actual, which is 2 ohms, divided by ang ating base is 7.68 ohms. So cancel yung ohms. So magiging per unit reactance is equal to 0.2604. Okay? So meron na tayong per unit reactance dun sa ating transmission line sa zone 2. And then para naman sa ating zone 3, kukunin natin is yung ating per unit reactance para sa transformer 2, and then yung ating per unit na impedance sa ating load. So para makuha natin yung ating per unit reactance sa transformer 2, kailangan muna nating i-convert yung ating base voltage from zone 2 to zone 3. So kanina dito sa ating calculation sa zone 2, nakuha na natin yung base voltage as 480 volts. So gagamitin uli natin yung ating conversion, which is yung ating transformer uli. So itong base voltage natin sa zone 2 ayun yung ating magiging 1. At tas yung yung magiging base voltage naman sa zone 3 ay yung ating magiging 2 dito sa ating illustration. So base voltage dito sa zone 3 is equal to base voltage 1 with respect to this diagram, which is yung nasa zone 2. So 480 volts times V rated 2, which is yung ating 115, divided by V rated 1, which is 460. Okay? So ang magiging base voltage natin sa zone 3 is equal to 120 volts. Okay? Since meron tayong per unit reactance dito sa ating transformer with respect to its rating, pero meron na tayong bagong base voltage which is 120. So dun sa transformer ang rating is 115. So i-calculate natin yung ating bagong per unit reactance, yung using naman yung ating equation 7 kanina. So yung ating per unit reactance new is equal to per unit reactance old, which is 0.10 times yung ating base voltage old divided by base voltage new squared. So yung ating base voltage old is 115, kasi 115 yung rating ng transformer, divided by 120, i-square natin yan, and then yung ating S new, which is 30 kVA, divided by ang S old, which is yung given, which is 20 kVA. Okay? So ang mangyayari dyan, pag kinalculate natin yan, ang magiging ating new per unit reactance sa ating transformer is equal to 0.1378 per unit. So ayan yung ating magiging bagong per unit reactance sa ating transformer 2, base dun sa ating bagong base voltage at bagong base power. Okay? Pagdating naman sa ating load, since meron na tayong base voltage at base power, so makukuha natin yung ating base impedance is equal to B voltage base squared divided by S base, which is equal to 120 squared divided by 30,000 or 30 kVA. Okay? So pag kinalculate natin yan, yung ating base impedance is magiging 0.48 ohms. Okay? And then so meron na tayong base impedance. So ang ating base current naman is equal to base power divided by base voltage. Okay? So equal to 30 kVA, 30,000 divided by 120. So magiging base current is equal to 30,000 divided by 120 is equal to 250 amperes. So meron na tayong base current sa load, meron na rin tayong base impedance sa load. Okay? So ngayon, dahil meron na tayong base impedance at meron na rin tayong actual impedance dun sa load, which is yung 0.9 plus J 0.2. So yung ating magiging Z per unit sa load is equal to yung actual, which is 0.9 plus J 0.2 divided by yung ating Z base, which is 0.48. Okay? So para ma-evaluate natin yan, convert muna natin yung ating rectangular form ng ating impedance to polar form. So 0.922 cis of 53 degrees divided by 0.48. Okay? And then divide natin yan, magiging C per unit is equal to magiging 1.921 cis of 12.53 degrees. And then convert uli natin yan sa rectangular. So 1.875 plus J 0.4167. Okay? So ayan yung ating per unit impedance dun sa ating load. So ngayon na-calculate na natin yung mga per unit values ng ating mga components sa bawat zones or sa entire network. I-convert naman natin ngayon yung ating single line diagram to impedance diagram, and then isusulat natin yung mga per unit values na na-calculate natin. So kung titignan natin dito sa ating impedance diagram, so nilagay na natin dito yung mga per unit values. Sa ating source, meron tayong voltage source per unit, which is equal to 0.9167 cis of 0 degrees. Sa ating transformer 1, meron tayong per unit reactance na 0.1. Sa line, meron tayong per unit reactance na 0.2604. Sa ating transformer 2, meron tayong per unit reactance na 0.1378. And then finally, sa ating load, meron tayong per unit impedance na 1.875 plus J 0.4167. So, since ang pinapahanap sa atin is yung current dito sa ating load in terms of per unit and in terms of amperes. So, dahil meron na tayong mga per unit values, meron tayong per unit voltage at meron tayong mga per unit impedances na nakaseries lang naman. So, madali natin makukuha yung per unit current, which is equal to I load per unit is equal to V source per unit divided by total impedance per unit. Okay? So, yung ating V source per unit is 0.9167 cis of 0 divided by yung total. So, i-add natin yung mga impedances natin. So, 1.875 plus J. So, add lang natin yan. 0.4167 plus 0.1 plus 0.2604 plus 0.1378. So, okay. So, pag inad natin lahat yan, magiging 0.9167 cis of 0 degrees divided by 1.875 plus J 0.9149. Okay. So, para ma-divide natin yan, i-convert uli natin ito sa ating polar form. So, magiging 0.9167 cis of 0. And then, itong ating itong ating numerator is equal to 2.086 cis of 26.01 degrees. Okay? So, pagka na-convert na natin yan, pwede natin ma-divide. So, 0.9167 divided by 2.086 is equal to 0.4395 cis of negative 26.01 degrees. So, yan yung ating yung I load per unit. Okay? So, yan yung sagot sa unang question na yung current in terms of per unit. So, ngayon, dahil meron na tayong per unit, so, IL per unit is equal to IL actual divided by IL base. So, kung marirecall natin kanina, itong IL base natin is equal to 250 amperes. Nakalculate natin kanina yan. And then, meron tayong IL per unit which is yung value na yan. So, therefore, yung ating I load actual is equal to IL per unit times IL base, which is equal to 0.4395 Cs of negative 26.01 degrees times 250 amperes. So therefore, yung magiging ating I load actual is equal to, so multiply natin 250 by 0.4395, ang lalabas dyan is 109.86 Cs of negative 26.01 amperes. So ito yung ating actual load current. Okay? Itong pinakita natin na example ng calculation ng per unit system is para sa single phase network. Pagdating naman sa three phase network, so similar din yung procedure, pero kung delta connected yung load, ay i-convert muna natin siya sa Y connected load. And then para gamit natin yung ating per unit sa power system analysis ng three phase network, is either pwede tayong gumamit ng three phase values tsaka line to line values ng ating mga base power at base voltage, or pwede naman tayong gumamit ng single phase lang, which is kailangan nating gamitin yung base power in terms of single phase, which is equal to yung base power in three phase divided by 3, and then yung ating base voltage na line to line is kailangan natin i-convert sa phase voltage, which is equal to line voltage divided by square root of 3. So pag nagawa na natin yung mga yon, is pwede na natin gamitin itong procedure na to sa pag-calculate ng ating line current using per unit system. Okay? So hanggang dito na lang po yung ating video, at sana may natutunan na naman kayo. At pinapasalamatan ko nga po uli yung ating mga subscribers na patuloy na sumusuporta, at inimbitahan ko na rin yung mga hindi pa po nakasubscribe na mag-subscribe na po sa ating channel. Maraming salamat po, at God bless sa inyong lahat.